Asteroids float through the void of space. Occasionally they collide, producing fragments that escape their orbits. When these fragments fall to Earth, they are called meteorites. For some reason, many meteorites have been discovered in Antarctica. Even more mysteriously, these meteorites are most often found at the base of mountain ranges. Why so many meteorites found at the foot of Antarctica's mountains? Join us as we unlock the secret. Mountain peaks and ridges loom above the snowy landscape. Here, Japanese scientists are on the hunt for meteorites. When a meteorite is found, a photograph is taken to record how it is situated. Meteorites found in Antarctica are free of contamination by terrestrial soil or organisms. They are very important scientific samples. So they are sealed in plastic bags to be taken away, untouched by human hands. Diameter 37 centimeters, weight 50 kilograms. Occasionally, meteorites as big as this are discovered. In a single day, the survey team has collected 49 meteorites. In comparison, the total number of meteorites discovered in Japan is only about 50. That's how common meteorites are in Antarctica. Japan's National Institute of Polar Research in Tokyo. A large number of meteorites gathered in Antarctica are kept in an underground storage room here, about 16,000 of them. Meteorites can be divided into two basic categories, iron and stony. The most commonly encountered is a type of stony meteorite called a chondrite. These are fragments of asteroids that failed to coalesce into larger planets during the formation of the solar system. These chunks of rock contain all the same materials from which the Earth and other planets were formed so long ago. They reveal the conditions under which our solar system developed. Iron meteorites like this one contain a great deal of iron. This meteorite was forged in the heart of a large planet. It provides clues to the understanding of planetary formation. Iron crystals can be seen in this cross-section. A planet's core cools slowly over many millennia, allowing large iron crystals like this to grow.
南極隕石はですね、南極大陸のその低温の気候に、ずっと置かれているためにですね、他の地域に比べて、非常に風化が進みにくいっていう特徴があります。そのためにですね、大昔に落下してきた隕石も保存されています。
This instrument is used to determine a meteorite's age. According to this method, the asteroids from which most meteorites originate were formed about 4.6 billion years ago. In other words, most meteorites are from the time when the Earth and the solar system formed. But where did they come from? Most meteorites are thought to come from the asteroid belt, which lies between the orbits of Mars and Jupiter. The asteroid belt is home to many small bodies. As these asteroids collide with each other and are tugged by the gravity of other planets, some are knocked from their orbits and end up striking the Earth. When that happens, we call them meteorites. But other meteorites actually come from the Moon. This is a rock from the surface of the Moon that fell to Earth. The face of the Moon is covered with craters. They mark places where meteorites struck the Moon in the past. When a large enough meteorite hits the Moon, rocks from the lunar surface are blasted out into space. Some of these fragments of rock land on Earth. These are lunar meteorites. The Apollo missions enabled people to bring back samples of sand and rock from the Moon. They provided a very limited sample for directly investigating the composition and structure of the Moon. But the discovery of lunar meteorites enabled scientists to gather information about areas of the Moon never visited by the Apollo landings. In Antarctica, even meteorites from Mars have been found. But how could anyone tell they were from Mars? In 1976, the Viking probe landed on Mars. It transmitted data back to Earth. This data matched the components of the gas found inside a meteorite, indicating that it had come from Mars. Even more interestingly, this meteorite contains shapes resembling terrestrial bacteria. Was it proof of life on Mars? The issue became a matter of debate. Meteorites like this are often found in a specific type of Antarctic terrain. On an ice field on the inland side of mountain ranges. Most of Antarctica's icy surface is covered in snow, but inland of mountain ranges, the ice is exposed in some places. Such areas are known as blue ice fields. Most meteorites are discovered in these fields. This area of Antarctic ice has been scoured by wind and sun. Why are so many meteorites found here? In 1974, Professor Yanai, a member of Japan's 15th research team, pondered exactly that question.
"なぜここにあるかっていうのは非常に不思議で、周りを見たらところどころに黒いのがあるんですね。全部確かめたら全部隕石だったんですね。隕石では地球の石ではないということで、これはどうもおかしいっていうことで、当時メンバー4人でしたけども、4人で、一生懸命探してみようということで、翌日から始めたら1日に10個とか多い時は100個ぐらい見つかったんですね。で、隕石がある場所は雪の上ではなくて氷の上ですね。氷の上にただ乗っかってるだけなんで、そこに落ちてきたと考えてもそれでもいいんですが、狭いところに何百個も落ちるってことは考えにくいんでですね、いろいろ考えて、もしかしたら氷に乗って運ばれてきたんではないかという仮説を作りました。
But does Antarctic ice actually move? The clue to solving that puzzle can be found at the South Pole. The position of the South Pole can be precisely determined using man-made satellites. Each year, a marker is driven into the ice at that point. Looking at these markers, it's easy to see that each one is about 10 meters off from the previous years. What is causing the South Pole markers to shift? The average thickness of Antarctica's ice cover is 2,300 meters. The sheer weight of the ice itself gradually forces it to move upwards toward the coast. Ice that is pushed toward the coast begins to overhang the shoreline and eventually breaks off to form icebergs. This ice movement is closely connected to the discovery of meteorites inland of mountain ranges. As meteorites fall on the vast Antarctic continent, they are entombed in the ice and carried along with it. If the moving ice reaches the coast, the meteorites will be plunged into the sea along with it. But if the moving ice comes up against a mountain range, it is stopped and protrudes up. Howling winds whittle away the ice at the base of the mountains, and the sun melts it. In the process, many meteorites are revealed. The Antarctic ice continues its slow march. As it moves, it carries meteorites, messengers to our world from outer space. And those messages may help us answer many questions about our solar system and animals of Antarctica. Only creatures like seals and penguins that have adapted to the frigid climate can survive here. But a startling discovery has been made in this land of snow and ice. The skeleton of a giant animal. A dinosaur fossil. Could dinosaurs really have lived in freezing Antarctica? Could they have coexisted with penguins? Dinosaurs chasing penguins? Were scenes like this played out sometime in the distant past? This is the story of Antarctica's dinosaur fossils. In 1994, a startling report appeared in an American scientific journal. Dinosaur fossils had been found in Antarctica. They were discovered at the base of Mount Kirkpatrick. This footage records the excavation of the fossils.
Oh man, what? Oh, altitude. You like them?
They were found in an area of ground exposed by the melting of ice in the summer. This stratum dates back 190 million years. The entire rock face containing the fossils was carved out and carried away. The discovery was made by a team led by American professor William Hammer. The dinosaur's femur, along with about half of the fossilized skeleton, came from here. The dinosaur fossil is being kept in the US at Augustana College in the state of Illinois.
Yeah, those ribs there too.
Professor Hammer began hunting fossils in Antarctica when he was still a student. After more than 10 years, in 1991, he finally found his first dinosaur fossil.
That'll be interesting.
Well, and this is really, really hard to prepare. In this drawer, we have parts of the pelvis. The pelvis of a dinosaur is made of 3 parts. A big flat blade ilium, which we'll see in the next drawer, and then these 2 parts project down from the ilium. This is called the pubis, and it projects down and forward. And this is called the ischium, and it projects down and back, like sort of like this, and then the flat bone fits up on top. In this particular slab, we actually have 4 pieces of the backbone from the middle of the back still articulated. That is still put together. 1, 2, 3, 4 pieces of the backbone. You can actually see 2 of the ribs coming off of the specimen there. Then on the other side of this piece, we have parts of the leg. This is actually the lower part of the bottom part of the leg, what we call the tibia, and this is the upper part of it.
This is part of a tooth. Its sharpness readily identifies it as belonging to a meat-eater. Here's part of the head. The most striking feature is the thin, plate-like crest above the eyes.
This dinosaur is named Cryolophosaurus. It's the first and only Jurassic dinosaur from Antarctica, or it's from the only Jurassic dinosaur fauna from Antarctica. The name Cryolophosaurus means frozen crested reptile, and that's in reference to the very unusual display crest right over the eyes on top of the head. You can see it curves forward and has a lot of ridges in it. It's very decorative. It's for display feature, probably for mating purposes.
Cryolophosaurus was a carnivorous dinosaur about 8 meters long. Carnivorous, so there must have been other animals living in Antarctica for it to eat. In fact, the fossils of a plant-eating dinosaur were discovered in the same location, and some plant fossils as well.
South Pole, and the climates were milder, probably more like cool temperate climates we see today, not real cold winters, not a lot of snowfall.
When Cryolophosaurus and other dinosaurs roamed Antarctica 190 million years ago, it was a much warmer place than it is now. We can visualize an environment of lush vegetation, inhabited by dinosaurs. Cryolophosaurus was one of the dinosaurs that roamed in those days. But now Antarctica is entombed in snow and ice, the coldest place on the face of the Earth. How could this ever have been a warm region? About 90 years ago, a German named Alfred Wegener proposed a theory. Sometime in the distant past, all the continents on Earth had been merged into one. To start with, Wegener believed, South America and Africa had once been a single landmass. To prove it, he turned his attention to fossils in ancient rock strata. For example, fossils of a reptile called the Mesosaurus, found in a stratum dating back 280 million years. Mesosaurus fossils had been found on both continents. Mesosaurus was not an aquatic creature, yet it was found on both continents. The only explanation was that they had once been connected. Wegener, originally a meteorologist, studied botany, zoology and geology in an effort to support his theory. He published his findings in a book entitled The Origin of Continents and Oceans. And what geological evidence did he provide? If South America and Africa were stuck together, the geological structures of the two continents would match up perfectly. He was firmly convinced that this constituted decisive proof. Wegener also began investigating the other continents and arrived at the conclusion that all the continents of the southern hemisphere, including Antarctica, had once been part of a single continent. It had split apart to form the continents that exist today. But because he could not answer the fundamental question of how the continents moved, his theory was rejected by leading geologists. Eventually, after Wegener's death, a variety of evidence came to light, proving that continents do in fact move. Surveys of the ocean beds between the continents revealed long undersea mountain chains. Scientists determined that the chains marked boundaries where sections of the Earth's crust were sliding past each other. Such discoveries made it clear that the continents are continually moving. The theory of plate tectonics convinced many people to accept the idea of continents in motion. In the distant past, the location of the Antarctic continent was different from where it is now. The climate was warmer as well. The fossils found in Antarctica are of dinosaurs that lived in that period.
Well, the winter days would be very short at high latitudes like they are today. Some days may have only had a few hours of sunlight. And that's a good question. As I said before, some of these, the dinosaurs might have been migratory.
Professor Hammer hypothesizes that when the days grew shorter and the vegetation withered away, the dinosaurs migrated to other connected continents. Antarctica once supported an environment where dinosaurs could live. To support the existence of the single meat-eating dinosaur dug up by Professor Hammer, there must have been many plant-eating dinosaurs.
Kind of working on the back a little bit.
Yeah.
Imagine an Antarctica of abundant life, a place that dinosaurs could call home. Dinosaur fossils from Antarctica tell the story of a time when Antarctica was a warm continent. By such discoveries, this mysterious continent speaks to us of its epic journey through the millennia.
The aurora spreads across the night sky above Antarctica. In times past, people had no idea what caused this atmospheric phenomenon. In the Middle Ages, some tried to explain it by suggesting that there were candles burning above the clouds. Later, advances in science and technology enabled many investigators to begin seeking the true explanation for the aurora. Today, we can observe the phenomenon from artificial satellites. The aurora occurs simultaneously at the North and South Poles. How can this mysterious aurora appear at exactly the same time at the two poles, so distant from each other? The first clue to explaining its mechanism came from an experiment conducted in the 19th century. It involved producing an artificial aurora. What makes the aurora shine? And why does it appear simultaneously at the North and South Poles? Late May. The sun is dipping below the horizon. Soon the polar night will begin, when the sun never rises all day long. The 40 days or so of polar night at Showa Base are the season for observing the aurora's beauty. If you watch closely, you can detect the rhythmic flickering of the aurora's shape and color. At Showa Base, the aurora's beauty can be seen on almost any clear day. The winter crew at Showa Base includes specialists who make detailed observations of the aurora. Data sent from satellites and observations made with large radar antennas are collected each day. Those who have seen the aurora for themselves always speak of its mysterious, enchanting appearance.
オーロラって一晩中出てるわけじゃなくて、ある時期に現れて、で15分ぐらいの間にものすごく頭上で渦を巻いて、やるんです。その時はですね、普通のスチール写真じゃ分かんないような非常に速い動きがあるんですね。から細かいひだがこう光るとかですね、そういう動きが非常に活発で、その動きは誰が見ても感動するんじゃないかなと思いますね。
In the past, people were utterly baffled as to the cause of the aurora's unearthly light in the night sky. Consequently, many considered it an ill omen, a harbinger of death. The 20th century marked the start of full-scale aurora observations in Antarctica. Japan's Showa Base is ideally located for such observation, so Japan has had an active aurora research program since 1957. This photograph of the aurora was taken by the first Japan Antarctic research expedition. This photo, transmitted electronically from Antarctica to Japan, was for many people their first glimpse of the dazzling aurora of the polar night skies. Later, with advances in science and technology, understanding of the aurora made rapid progress. For example, sending rockets to directly investigate the upper atmosphere where the aurora occurs has helped to explain the mechanism that causes the aurora. It is now known that the aurora occurs very high in the upper atmosphere, from 100 to 250 kilometers up, above the stratosphere, in near vacuum conditions. This picture of the aurora was taken from the space shuttle in orbit. Its curtain-like shape extending towards space can clearly be seen. Today, sharper pictures of the aurora can be taken than ever before. On the opposite side of the world from Antarctica, inside the Arctic Circle, lies Abisko, Sweden. It's famous for its auroral displays, captured here by an ultra-sensitive NHK TV camera. An identical TV camera was also taken to Antarctica to shoot the night sky. This allowed for a stunning demonstration that the Antarctic aurora was occurring simultaneously with the Arctic. The aurora occurring simultaneously at the two distant poles. The spectacle continues for almost 4 hours. But how does the aurora manifest itself at the North and South Poles at the same moment? The ultimate origin of the auroral lights is the sun. Charged particles like electrons and protons make up the so-called solar wind. Meanwhile, the Earth acts as a giant magnet, surrounded by magnetic force lines emanating from the poles. Because of this, the solar wind is deflected and cannot strike the Earth head-on. But sometimes, the charged particles become trapped behind the Earth. Then, they flow along the magnetic field lines and fall towards